All right, hey guys, in this video, I'm going to go over the problems from the practice quiz on exponential growth and decay. That was your homework from Monday evening. So in this video, I'm just going to go over the problems. So if you've done the problems and you want to know why on a particular problem, follow the video. If you have to skip ahead, that's fine too. So the first problem said a piece of machinery valued at $150,000 depreciates at a rate of 16% per year. How much will the machinery be worth after 3 years? Round to the nearest cent. All right, so we have to remember our formulas. Well, we don't actually have to memorize them. You can look in your notes and you'll notice that since it's depreciating, that means obviously it's decay. So our formula for exponential decay is A equals P times 1 minus our rate all to the t power. So our principal here is going to be 150,000. Our rate is going to be 16%, but we're going to change that to a decimal. And our time is going to be 3 years. So I'm just going to plug and chug here. So A equals 150,000 times 1 minus that rate, so 0.16, to the third power. So we could use Desmos and type this in exactly as is. Please see the first video that Ms. Cantwell put together on exponential growth and decay if you need help on plugging into Desmos. Or you can use a graphing calculator. And when you do so, you get $88,905.60. Desmos or your calculator will give you just 0.6, but we know that we're talking about money, so it should be 0.60. The second one is very similar, but just a different function here. So a car purchased for $24,000 is expected to lose value or depreciate at a rate of 8% per year. This situation can be modeled by V of t equals 24,000 0.92 to the t. Notice they've already done the math for us, the 1 minus that 0.08. That's where they got the 0.92 from. Where t is the number of years since the car was purchased. How much will the car be worth after 5 years? So again, we're just trying to figure out after 5 years the value of the car. So v of 5. All right, so 24,000 and then times 0.92 all to the 5th power. So we're just plugging into our calculator or into Desmos, whichever, and you should end up getting $15,817.96. So again, it was money, so that rounds accordingly. If you need help plugging in, please email me. I'll be happy to help. For the next one, it says you drink a beverage with 120 milligrams of caffeine. Each hour, the caffeine in your system decreases by about 12%. After how many hours will you have 10 milligrams of caffeine left in your system? And we're going to round to the nearest tenth. So with this one, again, we're not given a formula, so we have to come up with one. Because it says the caffeine is decreasing in our system, again, we're going to use the decay formula. So it's going to be A equals P 1 minus R to the t power. Right? Now, because we're asking how many hours, that means we're looking for t. So everything else we should be able to fill in. All right, so it's asking how long it's going to take to get 10 milligrams left in our system. So the 10 goes in the A spot. The P, what we start off with, is 120 milligrams. The rate is 12%, so we're going to change that to a decimal. And we don't know t. So there's our setup. All right, so what you can do, well, first of all, we can figure out what 1 minus 0.12 is. So make it a little bit nicer for us. So that's 0.88. You don't have to do that, but all right. So now our goal is to solve for t, right? So to do that, we want to eventually undo our exponential, but before we can get there, we're going to have to divide both sides by 120. All right, so I'm going to leave this literally as 10 over 120. I'm not going to turn it into a decimal. I'm going to leave it. All right, and then I want to undo this 0.88 base portion. All right, so what we want to do is we want to take the log of both sides. So the log of 0.8, base 0.88, log base 0.88. So that's going to cancel these out and get my t by itself. And now in my calculator, I write log base 0.88 of 10 over 120 and I get that answer of 19.4. So that's time, and time, let's see, was measured in hours. So hours. All right, and we could always figure out, well, what's zero point 0.4 of an hour? So 60 times zero point 0.4, that's 24 minutes. So 19 hours and 24 minutes. Okay. All right, and then the last problem says a drug is 95% effective as the previous hour. At some point, the patient needs a new dose, that should say dose, not does, after their initial dose of 250 milligrams. After how many hours will the drug reach a dangerously low level of 52 milligrams, round to the nearest tenth? So because we're decreasing, right, we could think of this as decay and 1 minus our rate, but we know it's 95% effective. So it's decreasing by 5%. So 1 minus 5% is going to be 95%. And we want to figure out how many hours. So we're figuring out time. The final level is 52. That's dangerously low. The 250 is where we start. Again, the rate is just going to be this 0.95 and then the t. So just like the last one, we're going to start off by dividing both sides by 250. All right, and again, I would just leave it as 52 over 250. I would not change it to a decimal. And then to undo the 0.95, we're going to take the log of both sides, but this time it's going to be log base 0.95. Log base 0.95. Okay, those cancel, giving me my t. We plug log base 0.95 of 52 over 250 into our calculators, and we should get 30.6. All right, because we round to the nearest tenth. That's how many hours. So 30 hours, and then you could, if you really wanted to, find out what that whole 0.6 means by finding 0.6 of an hour, which is 36 minutes. All right, so make sure if you have any specific questions to email me.